All right, welcome back. Today, we're jumping into a piece of tech that, honestly, feels like it's been ripped straight out of a sci-fi movie. Except, it's happening right now. We're talking about virtual worlds that don't just mirror our reality, they actively help run it.
Just let that sink in for a second. Imagine a perfect digital copy of a super complex real-world system. But it's not just there for you to look at or run a few simulations. What if it could make its own decisions and then take action in the real world? That is the wild idea we are unpacking today. Okay, but before we can get to the part where these systems can act all on their own, we've got to understand what they're built on. We have to start with the foundation, the digital twin itself. So, what is a digital twin, really? Think of it like a perfect digital mirror. Or maybe a digital shadow is a better way to put it. It's a virtual replica of something in the physical world, and it's being fed a constant stream of data, so it always, and I mean always, reflects the exact, up-to-the-second state of its real-world counterpart. The concept is actually pretty simple when you break it down like this. First, you've got the real thing. Let's say it's an oil rig way out in the ocean. Then you need a data bridge. This is a constant, non-stop flow of information coming from thousands of sensors. This is the whole Internet of Things, or IoT, you hear about. And finally, you have the virtual model itself, which takes all that data and evolves and changes right alongside the real rig. But here's the catch with your standard issue digital twin. It's a fantastic mirror, for sure, but it's totally passive. It can show you that a problem is brewing, but it can't actually do anything about it. It relies on a human to look at the screen, figure out what's wrong, and then go fix it. In other words, it's reactive, not proactive. And this is where it gets really, really cool. This is the moment AI steps into the picture and completely transforms that passive mirror into an active, intelligent agent. Let's look at how that massive leap is made. This slide just nails the difference, doesn't it? We're going from a system that is a passive observer to one that is an active participant. The old school twin just shows you the data, but the agentic twin, it understands the context behind that data. And this is the game changer. It can act on it to achieve a goal all by itself. So what is this agentic AI we keep talking about? Well, it's a special kind of AI that isn't just about crunching numbers. It can actually perceive its environment, reason its way through a problem, create a plan, and then, bam, execute that plan in the real world. And the crazy part? It learns from the results, so it just keeps getting smarter. It has agency. Let's make this super concrete with a factory example. Okay, so the digital twin detects a machine is overheating. A traditional twin, it would just flash a red light on a screen somewhere. But the agentic twin decides. Its goal is to stop the machine from breaking down while keeping production up. So it acts. It automatically slows down that one machine, reroutes its workload to other machines on the line, and at the same time puts in a work order for a maintenance check. All of that with zero human intervention. And, this isn't some far-off future theory. This stuff is already happening. So let's take a look at where this technology is already making a huge impact and why it matters so much. To give you a sense of scale, just look at this number. The potential economic impact in manufacturing alone is nearly $38 billion. We're not just talking about a new feature here. This is a fundamental shift in how entire industries are going to work. So in manufacturing, what does this look like? It means systems that don't just react to equipment failures, they predict and prevent them from ever happening. It means production lines that adjust themselves on the fly based on supply and demand. It even means entire supply chains that can basically govern themselves, automatically rerouting shipments to avoid delays. The bottom line? A massive reduction in super expensive downtime. And this goes way, way beyond the factory floor. In healthcare, we're starting to see digital twins of actual patients that help doctors plan treatments or even autonomously adjust medication being delivered by a smart device. And in smart cities, these systems can optimize traffic flow to cut down our commutes or coordinate an entire emergency response during a crisis, all happening in real time. Even in finance, the applications are just incredible. Picture this, an insurance claim for a car accident. A digital twin of the damaged car assesses the impact, the AI generates the full damage report, and an agent autonomously checks the claim against the policy, instantly flagging potential fraud and approving payment for the straightforward cases in a matter of minutes, not weeks. So that's what's happening right now. But you know how fast this technology moves, right? We have to ask, what does the future of these autonomous systems even look like? What's next? Well, the next giant leap on the horizon seems to be something people are calling cognitive twins. Now, if an agentic twin is all about doing things on its own, a cognitive twin is about understanding why it's doing them. This is where these systems go beyond just following orders and hitting targets.
I absolutely love this quote because it just captures the whole idea perfectly. Cognitive twins aren't just going to reflect our reality or act within it. They'll be able to understand, learn, and collaborate in ways that feel, well, deeply human. They're going to become our partners in actually creating and shaping the physical world, not just managing it. But of course, getting to that future is not going to be easy. There are some massive challenges. I mean, if you're going to hand over this much control, you need absolutely bulletproof data security. We have to be able to trust these systems, which means they need to be able to explain their decisions to us. And the sheer amount of computing power to make all this run in real time, it's just staggering. And that brings us right to the final, and maybe the most critical question of all. As we build these incredible systems that can see and think and act for us, we really have to start thinking about what that means for our own role. When the digital world isn't just a mirror anymore, but an active player on the field, what's our new job? What do we become? That's the real question, and it's definitely something to chew on.